Day 2 of section 1.3 focuses on how we end up with biased samples. Anytime we take a sample, there's two types of errors that we can have. The first is called sampling error, and this is natural, and it's actually not an error at all. It's the natural difference between the true population proportion of everyone in the population and the results that we get in our sample. More specifically, let's refer it to or relate it to M&Ms. Let's say 20% of all M&Ms are blue. If we open up a bag of M&Ms, pour them out and count them, we might only find that 18% are blue. If we open up another bag, we might find that 23% are blue. In another bag, it might be exactly 20%. Okay, so sampling error is just the natural variation of those differences when we take a sample and how that number is going to change in a sample around that true population proportion of 20% of all M&Ms being blue. Now we want to compare that to non-sampling error. This means that we have made an error. We could have made an error by asking the question incorrectly and ending up with biased sample results. We could have a measurement instrument that's giving us incorrect results, or just putting the data in incorrectly. So again, non-sampling error is just natural. It's going to happen. It's always going to be there. Non-sampling error is when we've actually made an error and there's something wrong with our data. All of these are going to focus on the second of those two errors, the non-sampling error, and how we produce biased samples. So the most common way we get biased samples is with a voluntary response sample. Most of the samples that you see are voluntary response samples. If people are asked to call in on the radio or click here to let us know your opinion of the president, mail-in polls, anytime you're opting in to a poll or a survey, you're likely to have a higher interest or a stronger opinion than someone who decides to ignore it. Taking a small sample is another way we could produce biased results. Let's go back to those 20% of M&Ms being blue. If we take a sample of 2 M&Ms, it's possible that none of them will be blue, in which case we have 0% blue, or both would be blue. In that case, 100% are blue. The best way we can get an accurate representation is to take as large of a sample as possible. And as that sample grows, we should see the percentage of blue M&Ms getting closer and closer to 20%. Self-interest studies are studies that are funded by some kind of big money interest. You see it a lot in politics, energy companies, those types of things. They want to see a result or lobbying to get some kind of result that helps their bottom line. And when we have the results of a sample, if we end up with any kind of precise number, in this example it's showing 10,312, we don't want to reuse that precise number. Instead, it's better just to round it and say it's about 10,000, because this is unlikely to be accurate. We never really can pinpoint precise numbers like that. All right, so we've taken our sample. Now we want to take our data and we want to organize it into some kind of display. We want to make sure it always abides by what's called the area principle. And the area principle just says that when we make a graph, we always want to make sure the area that's represented by our display corresponds with whatever the magnitude of that variable is. For example, in this display here, the question is how much bigger is the circle on the right? And if we look just at the diameters, okay, let's say we called the diameter of the circle on the left here 1. All right, the diameter of the circle on the right is 4 times as big. So this would be 4. But that circle is not 4 times as big. In fact, if we put 4 circles there, we can see the circle on the right is a lot more than 4 times as big. So if we were to just scale that linearly based on the diameter, we can see that the area grows a lot more than just the width of the circle. So we want to keep that in mind, and we want to stick to 2D graphs. We avoid 3D, and we want to choose displays that abide by the area rule. We're going to learn about a bunch of different displays as the course goes further along, but graphs like bar charts, pie charts, histograms, etc. Okay, moving on, there's something called a non-response when we do sampling. This is kind of the opposite of voluntary response, and this is when we ask a person a question and they refuse to answer. It's likely that they're refusing to answer because they're different in some way than the people who are willing to answer. So their absence in a survey is likely biasing our results. This is another common one. They're called loaded questions, and it's when the wording of a survey question is designed to kind of steer you towards a specific result. And these can be somewhat subtle. Here's two examples. Should the president have the line item veto to eliminate waste? Should the president have the line item veto or not? The bottom one here is an unbiased question. You're going to answer yes or no whether you think the president should have the line item veto. The top one, it's asking about eliminating waste. Everyone wants to eliminate waste. Yes. Okay. The top one's going to have a lot more people responding yes than the bottom one. This next example, too little money is being spent on assistance to the poor versus too little money is being spent on welfare. Welfare is assistance to the poor, but it's a very loaded word. And as soon as you include this word, support is going to drop for that question. So this is going to be a much lower supported question than the top question. Correlation and causality was touched upon in the last video, but to summarize, it's saying that although we might have an association between two variables, it doesn't necessarily mean that we can say one variable is causing the other. For example, there's a correlation between the number of lemons imported from Mexico and US highway deaths. This is a negative correlation. This is real data. We can see that over time, the number of lemons increased and the US fatality rate on highways decreased. So to reduce highway deaths, we should import more lemons. That's obviously not true. It's just as time went on, there was a higher demand for lemon and safety standards increased in cars. Lastly, always make sure you're not being misled and you're not being painted a partial picture. Here we have two different graphs showing the same data. This left graph is appropriate. It's honest. It's showing the correct scale on the left side from 0 to 400, and that's displaying the difference in median weekly income for men versus women. On the right graph, it's going to change the scale, shifting it from 300 to 400 instead of 0 to 400, and it looks like this is a much bigger difference, especially if we took these numbers out, which is the next step into making it look like that number is a lot higher for men.